In this video, we're going to talk about solving logarithmic equations. Of course, to solve a logarithmic equation, we'll have to apply its inverse function. We'll have to exponentiate both sides. So let's see how that works. If I take a look at my logarithmic equation here, I notice I've got a base 5. So what I'm going to do is I'd like to match that up with a power with the same base. So I'm going to raise both sides as the exponents. So I've got tiny little exponents here. And the base I'm going to put in is the one that matches my logarithm. So it's like I'm putting those two sides up, the entire side on hydraulics, and propping them up with a big base 5. Okay? Now on the left-hand side, I see I've got a power of a single logarithm, and the bases match. They're going to perfectly unlock each other. I'm just going to be left with 9x plus 23. On the right-hand side, I'm going to have 5 to the 3, so 5 cubed, which is 125. So we can solve that linear equation. I think 102 is divisible by 3. It's 34. Okay. So there we have our solution to our equation. And of course, we should check it back in here. All right? So in terms of our tactics, what we're going to do is we're going to isolate the logarithm on one side of the equation, if we can do that, and then we'll raise both sides of the equation as exponents of the same base. You can't choose just parts of it. The whole side has to go up as one single exponent. And then you prop it up with some big base of your choosing. All right, let's try another example here. So here we've got our logarithm already isolated, so we can go ahead and just raise both sides as the exponents of a base 7. Now on the left-hand side, we have a power where the exponent is a single logarithm and nothing else. The bases match, so they perfectly unlock each other. We're just left with 8q plus 4. And on the right hand, we've got 7 squared, which is 49. And we've got a nice linear equation to solve. So there we have it. Let's try another example here. Okay. Here we've got multiple logarithms. Thankfully, they all have the same base, so that's going to be helpful. But I would like to have just one logarithm if I could. So let's bring them all over to the same side. At least we'll do that. And think about how we could combine those two logarithms into one. That's exactly why we have the log laws, so we can do stuff like that. We can simplify that logarithmic expression. Notice we've got one logarithm minus another. They have the exact same base. Well, that looks exactly like the result if we had a log base 6 of the first argument divided by the second one. That's one of our log laws. Okay? Often we use it in reverse, but of course the log laws are equations. They can go both ways. So now I have a single logarithm isolated on one side, so I can raise both sides as the exponent of base 6. Okay, so we've got on the left-hand side a perfect pair that are going to unlock each other. And on the right-hand side, let's quickly grab my calculator here. We've got 6 to the 4. And that gives us 1,296. A pretty big number. All right, let's keep going. Now we've got a rational equation. So let's cross multiply. So we get 2,592y plus 3,888. Okay, so We'll bring our y's all over to the left there. This is looking like a pretty horrendous number. There it is. That's our potential solution there. But before we say for a fact that is the solution, let's take a look back at our original equation. Okay? If we take a look here, take a look at that first logarithmic expression there. Log base 6 of y plus 1. If I look at this y value we've got, it looks absolutely terrible. But if you notice, the numerator is larger than the denominator. So in absolute value, that number is bigger than 1. But it's a negative number. So it looks around maybe negative 1.5 or so. Now if I look at my expression there, and the one that I've underlined in red, if I try to plug in a number around negative 1.5 for y there, I'm going to get a negative number in the heart of my logarithm, in the argument. And that can never happen. We can never plug in 0 into a logarithm or a negative number. Okay? So our value here is not going to pass the check. So as a result, our equation actually has no solutions whatsoever. So please try some examples on your own. Take a look at the web work. And just remember, you need to take the entire side when you're ready to exponentiate and put the entire side up as the exponent of a base of your choosing.